Welcome to Engineering Systems. So for the last few episodes, we've been digging deep into the theory of distributed consistency. But now, it's time to get practical. In this final part of our series, we're going to see how all these patterns actually come to life in the real world. Okay, let's just jump right in with a question that honestly trips up a lot of engineers. You look at a massive production system, let's say a big e-commerce site. Is it strongly consistent? Or is it eventually consistent? Kind of feels like it has to be one or the other, doesn't it? Well, here's the thing. The answer is kind of both, and also neither. The reality is actually way more interesting. A large-scale system isn't just one monolithic thing. It's more like a patchwork quilt, a mosaic of different consistency guarantees, all working together. And learning how to pick the right piece for the right spot, well, that's where the real engineering craft comes in. Throughout this series, we've built up a pretty powerful vocabulary, right? We've covered strong consistency for that absolute correctness. We've talked about eventual consistency for massive availability. We even explored the more nuanced, user-focused models like read your rights and the logical ordering of causal consistency. And now we finally get to put all these tools to work. So here's the plan for today. We're going to bust the myth that it's a one-size-fits-all decision. Then we'll get our hands dirty with a real-world e-commerce example to see these ideas in action. After that, we'll lay out a framework so you can choose with intent. We'll wrap up by looking at the full spectrum of choices, and then we'll peek at what's coming next for engineering systems. All right, let's kick things off with what is, maybe the most important takeaway of this whole series, this idea that you don't just pick one model and apply it everywhere. And it boils down to this simple, powerful idea. Consistency isn't a system-level decision, it's a feature-level one. The guarantees you need for a financial transaction are completely different from what you need for a like button. Let's really see what that means. And to make this super concrete, let's just walk through an example we all know, a standard e-commerce platform. We're going to break it down component by component and figure out which consistency model fits where. First up, the heart of the operation, the inventory service. The rule here is super simple, absolutely non-negotiable. You cannot sell something you don't have. If there are 2 items left in stock, only 2 people can buy them. End of story. Correctness is everything, which makes strong consistency the only real choice here to prevent overselling. Okay, but now, what about product reviews? If a user posts a review, does every single person on Earth need to see it that exact same nanosecond? No, of course not. A delay of a few seconds, maybe even a minute, totally fine. So here, we can loosen the reins, go with eventual consistency, and prioritize keeping the site up and fast over that immediate correctness. All right, now think about a user updating their own profile, maybe their shipping address. When you hit that save button, you absolutely expect to see your new address right away. If you don't, you start thinking, did that even work? This is a classic case for read your rights. It makes sure you see your own changes, building trust without needing to sync that change across the entire globe instantly. And what about conversations? Like in a comment thread on a product, the order of replies is critical, right? A reply has to come after the comment it's replying to. That's a cause and effect relationship, and that is exactly what causal consistency is designed for. It keeps the conversation logical without the heavy cost of a strict global ordering. And finally, let's look at the analytics dashboard. So what if the dashboard says there are, say, 10,002 active users, but the real number at that exact second is 10,005? What's the business impact? It's basically 0. This is the perfect place to relax our guarantees all the way, using weak or eventual consistency to make things fast instead of perfectly precise. Okay, so seeing how all of these different pieces fit together, it naturally leads to the big question. How do you, as the engineer, actually make these calls? How do you choose with intent? Well, it really all boils down to one fundamental trade-off. The stronger the guarantee you ask for, like absolute perfect correctness, the more you have to pay for it. And that price comes in the form of more coordination between your servers, which means higher latency for your users and often less availability. In distributed systems, there's just no such thing as a free lunch. So here's a simple 3-step mental model you can use. First, assess the risk. Just ask yourself, what is the absolute worst thing that could happen if this data is a little stale? Second, analyze the business impact. Are we going to lose money? Is a user's security compromised? And finally, step 3, you choose. But the key is you don't just default to the strongest model. You choose the one that's sufficient. Don't pay for guarantees you don't actually need. Okay, let's zoom out one last time and put everything back onto that spectrum we've been building throughout this whole series. So on one extreme, you've got strong consistency. That's your maximum correctness, but it's also your highest cost in terms of coordination and latency. Then, as you move across the spectrum through models like Causal, Read Your Rights, and Eventual, you're making a conscious choice to trade a little bit of that correctness for better performance and availability. And all the way at the other end, you have weak consistency, maximum availability, but with the fewest guarantees. And this brings us to what I think is the single most important lesson of this entire series. Consistency isn't a default setting. It is a deliberate design decision. It's a trade-off you make, thoughtfully, based on risks, business needs, and the kind of user experience you're trying to build. And with that, we've pretty much covered the consistency landscape. But you might have noticed a theme, right? Every choice we made involved a trade-off with performance and availability. So it's probably time we talked about the other side of that equation. So this officially concludes our series on consistency patterns. But don't worry, we're not done. For our next big series here on engineering systems, we're diving headfirst into availability patterns. We're going to explore how systems stay up, how they handle failures, and what it really takes to build resilient software. If you're interested in building systems that can actually survive in the real world, you're not going to want to miss it. So make sure you subscribe to Engineering Systems, and you'll get notified the moment that new series drops. Thank you so much for watching and for coming along on this deep dive with me. We are just getting started.